So one of the things I hear a lot is the idea that everything needs to be mocked. And it usually frustrates a little bit of me with testing because, as you know, I'm very data-oriented. Go is very data-oriented. And for me, the best tests are the ones that are data-oriented, concrete data in, concrete data out, and we do those testing. I'm not saying that you can't mock, and I'm not saying you shouldn't mock, but for me, mocking is kind of that last resort. And a lot of times we could just refactor our code a little bit to make it more testable. But I think another beautiful part of Go's compiler, the ability of having that convention over configuration and the static code analysis, is that the responsibility for mocking has moved away from the developer writing the API to the developer using the API. I think it's one of the really nice aspects of some of this feature functionality that Go has added here. I want to show you some of that so you can start to think about that in terms of design. So imagine a situation where a client comes to me and says, Bill, we're going to implement, I need a Go version of our pub sub API. And I say, well, tell me a little bit more. And they're going to say, you know, we have an internal messaging bus that we use. We don't use RabbitMQ. We don't use anybody else's. We've implemented our own. And developers are allowed to talk to this message bus and other services in any language that they want. So imagine this is what they've done. They've created a message bus. There it is. And what they say is everybody who's writing services, what you do is connect to this bus, you pub sub, and this is how we do microservices. Not necessarily a bad idea, but then this is what they're doing. And they're saying, Bill, we already have programs written in Java and Python today, C, C++ today, some C#. The beautiful thing about the message bus is it doesn't matter really what language you're talking about. It's all message passing. And what we'd like to do, Bill, is add Go. So do you think you could write a package in Go that implements all the binary protocols and everything that we do as it relates to this message bus? And so one of the first questions that I'm going to ask is, how many message buses are there? And they're going to say, no, Bill, just this one. So I only have to worry about implementing this one message bus. That's right. So already, even though I'm going to have a concrete implementation of this first, I already know up front that I don't have a decoupling problem here, right? Like, there's only one implementation that I have to have. There's only one physical bus, one physical set of protocols. What's beautiful is once I finish my concrete implementation, I really don't have to worry about in interfaces or decoupling or anything like that. So I go ahead and I do this work. I define my pub sub type, and I define that factory function that constructs and returns that pub sub pointer, and then I implement, let's say, 10 methods as part of the API. Whatever the API is, I implement 10 methods in a very Go idiomatic API. And I'm done with this API, and now I want to write tests. So one of the things that I'm going to go after first is, I could write mocks for my tests, but one, I don't need mocks as it relates to the API itself. But two, I mean, I've got real binary protocols here. If I could write tests that talk to a real message bus, life would be much better for me. I could sleep at night knowing, not guessing, but knowing that this is working, because my mocks are also a re-implementation of those internals, right? And what's one of the nice things about Docker as a tech is we could probably wrap this message bus in a Docker container and then run our tests against that directly. I love Docker for these types of things. I do it with databases as well. So let's just say we did that. I wrap a message bus in a Docker container, and I write tests that hit that message bus directly. And I go to that developer who's going to be writing those Go services, and I say, OK, this package is ready for you. Go start writing your code. And a couple days later, what happens? You know, that developer's writing some code, and now they want to write tests. And they come to me and say, Bill, I've got a problem. I got to write tests, and I have to mock my tests because I can't hit real message buses in my test environment. And I look at them and I go, you know what, you're probably right. You probably are in a situation where mocking the message bus is the right thing for you, because you should assume that I'm doing my job in my API. And you shouldn't worry that all of those message bus calls you're going to make, right? Those pub sub calls are not working. Like, that's not your job. I've guaranteed that. So you're probably mocking for you is okay. And they're going to say, well, Bill, I appreciate that you said that. Hey, can you give me an interface that I can leverage to write these tests? Because remember, when they're coming from other languages, those interfaces have to be declared against those concrete types like pub sub in order for them to be able to do this type of mocking. And I have to remind them, I have to say, hey, wait a second, this is Go. I don't need to give you these interfaces. What's beautiful here is that if you have a mocking need, you can do the mocking yourself. You can actually define those interfaces yourself. I could turn around and tell that developer, look, you go ahead and do what I'm doing on line 14 in this new piece of code. Why don't you define your own publisher interface and lay out just the methods from the API that you're using and in the order that you need them in there. You could define your entire own set of interfaces that my concrete type satisfies. And then throughout your entire app, you use that publisher interface, right? Or different versions of that publisher interface through composition, so our APIs are precise. I don't need to do that for you anymore. You can do it yourself. And here's an example where that publisher interface, my concrete value, even though I didn't implement the interface itself, my concrete type satisfies that interface. And now that developer can go ahead and write their mock. They can implement a mock implementation of PubSub for their tests. They can use my concrete implementation for their app. And what's nice is they can do the construction of either or depending on where they are in the code base. This is, I think, again, one of Go's big legacies that are going to be moving forward in other languages. The idea that the developer writing the API doesn't have to think about the user's tests, doesn't have to think about the decoupling needs for someone else. So if I'm adding an interface to my package, it's because I need that interface. I need to start asking for data based on not what it is, but what it does. I don't have to worry about what the user of my API needs. They can satisfy their own requirements. So it's going to keep code minimized and really clean and concise throughout our entire code base, because everybody can just take focus and responsibility for what they need. So again, interfaces can provide that mocking support. I want to use it as a last resort. You know, if we can use those Docker containers to put real tech in there to test, let's do that. We don't have to worry about somebody else's tests or other mocking needs. They can write their own interfaces to handle that. And I always just want to make sure, again, as we've been talking about, we're gonna not design with interfaces, right? We're gonna discover them, and everybody can discover the interfaces that they need for themselves.